Okay, so here are a few examples when it comes to using the unit circle when solving trig or solving equations. Okay, so starting off with this one, sine x equals 0. The domain is from negative 360 to positive 360, so we're definitely in degrees. So of course you take the inverse and you ask yourself where on your unit circle in degrees is sine 0. Well, that happens right here as well as right here. So your values are going to be 0, 180, and 360 going in the counterclockwise direction, and then negative 180 and negative 360 going in the clockwise direction. With this one, again, we're in degrees because we're going from negative 360 to positive 360. But you're going to do a little bit of work before we actually can get to the part of writing a circle. This is being squared, so we have to get rid of it. So we take the square root of both sides. You have to remember when you take the square root of both sides, it's a positive or negative of whatever that number is. Whenever you square a fraction, you square the top as well as the bottom. Well, the square root of 1 is 1. Square root of 2 is not a perfect square. So we have to rationalize it to get a radical out of the denominator. So cosine of x is actually equal to positive or negative square root 2 over 2. Again, you take the inverse. And you're looking for all the values, or all the cosines where it's a positive square root 2 over 2 and a negative square root 2 over 2. That's at 45, 135, 225, and 315. Okay, so that's a positive root 2, negative root 2 over 2, negative root 2 over 2, positive root 2 over 2. And then, of course, the negatives. This time we're in radians. Negative 2 pi to a positive 2 pi. Tangent theta equals 0. Okay? You are going to take the inverse of tangent and see where does tangent equal 0. Well, you have to remember that tangent is sine over cosine. Okay? So you're looking for the values, the order of pairs, and when you divide the y value by the x value, you're going to get 0. Well, that only happens when sine is 0 and cosine is 1 or negative 1. So that's going to happen on our unit circle here and here. So our values are 0, pi, 2 pi, negative pi, and negative 2 pi. Now hopefully you watched the first original video, so these are all the examples. What I suggest you guys to do is to pause the video, try the problem out yourself, and when you're ready to see how well you did, just go ahead and press play because the explanation comes along with it. All right? Here's the next one. We're from negative 2 pi to positive 2 pi. Sine theta equals cosine theta. All right, so for this one, hopefully you divided both sides by cosine to get that tangent theta, because sine over cosine is tangent theta, equals 1, yes? So then you took the inverse of tangent and ask yourself where on your unit circle is tangent 1? Well, that means you basically have the same thing, right? So that's here and here. So going in the counterclockwise direction, that would have been pi over 4 and 5 pi over 4. But going in the clockwise direction is not negative pi over 4 and negative 5 pi over 4. You've only gone a little bit over pi over 2, which is actually a negative 3 pi over 4. And then a negative 7 pi over 4. All right? All right, here's the next one. Watch that domain. Be careful. So with this one, you have to check your domain. Be very careful. You're going from a negative 180, which is going this way in the clockwise direction, and then going around twice in the counterclockwise direction to get to 720. Okay? So you have to do the inverse, of course. and ask yourself where cosine is 1. Okay, cosine is 1 here at that particular value. That value is 0. If I went in the clockwise direction, I can only go up to negative 180, but their cosine is actually a negative 1. So going around in the counterclockwise direction, the next time I'll be at that point is at 360, and then again at 720. So good job. Clear boards. Lots of practice, guys. Yes, lots of practice. Here's one. Watch the domain. Yes, you might have to do a little bit of work here. But this one, yes, you're going to have to do a little bit of math before you can actually get to the part where you look at your unit circle. You add 1, divide by 3, take the square root, and I believe you cannot forget about the plus or minus, correct? Okay, so now look at your domain. When you're in degrees and you're actually traveling a pretty far distance, okay? But it's positive and negative, so it's pretty much in every single quadrant. The first one was 60, correct? Yes, because you're looking for a sine and cosine value where things will cancel out and you're left with just a root 3. So that's when the y value is square root 3 over 2 and the x value is 1/2. So that's going to give you going in the counterclockwise direction 60 degrees, 120, 240, and 300. Yes? Okay. Now, to continue going another full rotation, guys, all you do is a full rotation is how many degrees? 360. So all you have to do is add 360 to these 4 values. So 60 plus 360 is 420. 360 plus 120 is 480. 360 plus 240 is 600. And 300 plus 360 is 660. Now, if you kept going after that, you would have gone past the end of your range. Now, we do have to include the negatives. So we're going basically the same distance and only till a negative 180. So that's going to be a negative 60 and then a negative 120. So it's all those values.
Oh goodness, I'm so many values.
All right?
What value?
Here's the next one. Fix this domain. It should be a negative pi to a positive pi. And here's this one. A little bit of math before. So you subtract 3. That turns to a negative 1. Divided by 2 to give you a negative 1/2. You are going to end up doing the inverse. So you have to ask yourself, where is sine a negative 1/2? I.e., where on your unit circle is the y value a negative 1/2? That's going to occur here as well as here. Since we're only restricted in between a negative pi and a positive pi, you're going to have 2 values. It's going to be a negative pi over 6 and a negative 5 pi over 6. Yes? Good stuff. Here's the next one. Fix this domain here. Negative pi, positive pi. A little bit of math, of course, beforehand. Before we can actually get to the unit circle, you have a 3. You divide by 4, and then you have to take the square root. When you take the square root, you have to remember your plus or minus, okay? And when you take the square root, just like that other problem, you're taking the square root of the top and the bottom. So it's going to be the square root of 3 over 2, because 4 is a perfect square. No need to rationalize anything here, because 4 is the perfect square. So now you're looking on your unit circle only between positive pi and negative pi for a root 3 over 2 and a negative root 3 over 2. So going in the counterclockwise direction, that should have been pi over 6, 5 pi over 6, yes? And then going in the clockwise direction, that would have been here and here. So negative pi over 6 and negative 5 pi over 6. Questions? 2 sine x plus 1 equals 0. Sine x plus 1 equals 0. Negative 1 and negative 1/2. So where in the circle does that happen? That happened at 7 pi over 6 and 11 pi over 6. And then negative 1 was at 3 pi over 2. Good stuff. Okay, here's the next one. Negative 15 and 165. Remember that 2x means you need to change the domain, so it would have been from negative 360 to a positive 360. And you had to figure out where is cosine square root of 3 over 2. Well, that happened at 30 degrees and 330, as well as negative 330 and negative 330. But every single one of those was equal to a 2x. So you did have to divide everything by 2 before you actually got your final answer, which would have been 15, 165, negative 15, and then negative 165. Okay? Here's the next one. So with this one, you do have to change your domain. So it'll be negative 3 pi to a positive 3 pi. So you're basically asking yourself, where does tangent equal 1? Well, tangent equal 1 at pi over 4. It also equals 1 at, 5 pi over 4? And then going all the way up to 3 pi, which is a full time around and then halfway, you're also at 9 pi over 4. Okay? So that covers from 0 to pi over 3. Then going in the clockwise direction, it would have been a negative 3 pi over 4, a negative 7 pi over 4, and then a negative 11 pi over 4. Okay? So then every single one of those had to be equal to a 3x, and so you would have had to divide everything by 3. When you divide, remember, you multiply by the reciprocal, so one of your solutions is a pi over 12. When you divide this by 3, you'll get a 5 pi over 12. Divide this by 3, you'll get a 9 pi over 12. And what does 9 pi over 12 reduce down to be? What is it? 3 pi over 4. This one is going to be equal to a 3x, so when you divide by 3, you'll get a negative 3 pi over 12, but that reduces down to be what? Over 4. Set this one equal to 3x, this will give you a negative 7 pi over 12, and then this one will give you a negative 11 pi over 12, and those would be your solutions for this one. Definitely a doozy.